So now I'm going to review a little bit of algebra. Now, I will preface this with saying that I'm not a math teacher, so I'm not really sure how they teach you this in math classes anymore, but I'll just teach you the little tricks that I know that I learned when I was learning algebra that are enough for you to be able to really solve any problem in your honors Chem 1 class. So we already looked at and have been looking at this equation of density is equal to mass divided by volume. So if I wanted to, say, solve for the mass of something, right? So I've been told what its density is, and I've been told what its volume is, and I just want to be able to calculate what the mass is. What I need to do is I need to get the mass by itself. So in order to get the mass by itself, I have to do the opposite operation here in order to get the volume to cancel on this side, right? And then what I do to one side, I do to the other. That's almost all of the algebra I know, and I can do a lot of chemistry and physics. So if you look at this equation right here, you have, you want the mass by itself, so mass is being divided by volume. Sorry, my hand was in the way. Mass is being divided by volume. So in order to get the volume to cancel, I have to do the opposite of division, which is multiplication. So I multiply on this side by V, right? And what that will end up doing is it will make the volume cancel here. And then what I do to one side, I would do to the other. So I would have to multiply by V over here. So ultimately what I get is volume times density is equal to mass. Now let's say I wanted to start with the same equation here. But instead, I wanted to now solve for the volume. Let's say I've been given the density and I've been given the mass. Now, there's a few different ways that you can do this, but what I've seen, mistake that I've seen kids make over the years is what they want to do is they just want to divide by mass, right? So they want to divide by mass over here and get it to cancel and then do it over here. But if you do that, what you're left with is not V, you are left with 1 over V, and then you would have to flip this upside down. So what I tell my students is that anytime there's a fraction, you want to try and get the variable off the bottom of the fraction. Even if it takes 2 steps, I always start by getting numbers or getting variables off the bottom of the fraction. So here I would start by multiplying by V on both sides, right? So like I did there, and I multiply by V, so here I am again at this. And then in order to get the volume by itself, now I have volume times density, so the opposite of multiplication there would be division, so I'd have to divide by density here to make it cancel, and what I do to one side, I do to the other. So I would divide over here, and so what I'm left with is volume is equal to m divided by the density, right? I'm going to show you another common equation because we've been working a lot with this density equation. This is the equation for heat energy. So don't really worry about what the variables mean. It's more about the algebraic operation. So let's say the equation is Q is equal to mass times C times the change in temperature, right? So I have this times this times this. So if I were given the energy and the C, which is specific heat, and the change in temperature, and I wanted to solve for mass, then what I would have to do is look and see, okay, I want mass by itself, and it's being multiplied by these two numbers. So I'm going to have to divide by those two. So I can do it at the same time, and I'm going to divide by C and change in T at the same time. They're going to cancel, and what I do to one side, I have to do the other. So I'm going to divide by C and change in T over here. And so what I'm left with is if I want to solve for mass, I take Q and I divide by C times the change in T, which is equal to M. Now, in your calculator, if you're going to punch this in, the other thing that I always tell students is that you want to divide the number if it's on the bottom of the fraction. So a common mistake kids use or have when they use their calculator in terms of order of operations is they would take whatever that number is and they would divide by this and then multiply by that. In order for that to work, you have to put this in parentheses and make your calculator do this operation first, right? Because you want to divide by those two numbers multiplied by together. So in order to avoid having to use parentheses in the calculator and remember them, I just kind of keep in my head that if a number is on the top of a fraction, I multiply. If it's on the bottom of the fraction, I divide. So how I would punch this into my calculator is I would take that number and I would divide by this and divide by that. Because these are both on the bottom of the fraction, they get divided. And if you kind of keep that in mind, just multiply what's on top and divide what's on the bottom, then you never have to worry about parentheses and you won't screw up order of operations. I'm going to show you one more little trick that I use, and what we're going to need to use when we're learning about gas laws is cross multiplying, right? So one of our gas laws is, it's called Charles' law, which says that the initial volume of something over the initial temperature of something is equal to the final volume over something and the final temperature over something. So this is sort of a ratio, and you have to keep them together, right? So V1 T1 equals V2 T2. So in this case, if I wanted to solve for, say, T1, right? Let's say I'm told the initial volume, the final volume, and the final temperature, but I need to know the initial temperature, right? I want to solve for this T1. So whenever I have these fractions like this, I cross multiply. And so when you cross multiply, basically it means that this times this is equal to this times this. This is my cross multiplication. So I get V1 times T2. Hold on, let me get the lights back on. There we go. And then we have V2 times T1. Right? Now, I'm not quite there yet. I still need to get T1 by itself, but at least I get all of my variables off the bottoms of my fractions, and I don't have to worry about, the mistake up here where we end up with 1 over V or something like that. So I usually just cross multiply at first when I have fractions, and then I can look and I can see, all right, I need to get T1 by itself. That was my question. So here they're multiplied by each other, so I just need to divide by V2 to get it cancel. And what I do to one side, I do to the other. And so I'm just left with V1 times T2 over V2 equals T1. Right? So those are just some algebraic tricks that I use, and you'll hear me use as I try to teach you how to do some of the calculations that we'll be doing with quantities in chemistry.